Okay, so let me just talk about our pages of notes. On the first page, these are all of our calculator instructions, and if you are watching this video, you will want to have the copy of the notes so you can reference this as I go through. This whole page is just steps on how you use the graphing calculator to do trig regression models. What I'm going to have on the screen while we work is the actual examples so I can go through the process on a graphing calculator. So Professor Barney and his assistant Otis are trying to decide where to spend their spring break. Barney favors Chicago, while Otis would like to go to Honolulu. Using the information given in the table below, help them to make a decision. The table gives the normal daily high temperatures for Honolulu, H, and Chicago, C, in degrees Fahrenheit for month T, with T1 corresponding to January. So just to explain, January, February, March, April, May, June, July. So this is, they put a numerical value in for each month of the year, and then they've listed Honolulu as the next line and Chicago for the next line. So we're going to find a trigonometric model for Honolulu first. So this is what we're going to do. We're going to take our calculators, and I'm going to get this all where I can get it all on the screen. You're going to hit your stat key, this one right here, stat. And then we are going to go in and edit, so that's the first thing that comes up. You can just hit enter. And you should have lists that say list 1, list 2, list 3. There may be information in there because we've used this before. If you go to the top and highlight, for example, L1, hit your clear key and enter, it will clear all of that out so you have a clean slate. So we are going to type in all of the 12 months in the first column, so go ahead and do that now. So 1 through 12. Yes.
For some reason it has 1 E0, 2 E0, 3 E0, 4 E0.
Bring it up and I'll fix it. Okay, so on the L2, since we're doing Honolulu, you can start putting the data for Honolulu in with the month of the year.
Is it because I'm in radians?
No, it's because you're in engineering mode instead of normal.
That's weird.
Yeah, somebody messed with it. Okay, so we're going to put in all of the data. So if January in Honolulu is 80.1, February is 80.5. So we're going to get all of that typed in. 84.7, 86.5.
If we put all that in list 1, can we put the other stuff in list 2?
So you're putting 1 through 12 in list 1.
But like if I already did it.
And you put all the other stuff in list 2. If you get them mixed up, you're going to have extra steps.
Shocker, dude.
So I would just go back and fix it. You do want to be careful because the way that the defaults are, you want to have your independent variable in list 1, which would be time, and your dependent variable, which is temperature, in list 2. So you do want to be careful. So sorry this is taking so long. So put all of our information in. And if you're doing this for an assignment, you'll want to take time to go back and make sure that all of the numbers were entered correctly. You also want to make sure that the last month of the year lines up with your last data point. Otherwise, you're going to get half of a coordinate pair, and the calculator will give you an error code.
Do I need to put it in Chicago too?
So we're just putting in Honolulu,
Okay.
no Chicago. So we're just doing Honolulu first. Okay, so we're going to put all of that in here. And then, so that is the whole first section on your other page on entering the data. So that's our X and Y, our independent, dependent variable for Honolulu. Then what we do next, which makes this easier, it's going to set up our graph in the window all in one step, is you're going to hit the zoom key, and we want zoom stat. Actually, I take that back. I think we actually want zoom trig.
Yeah, 'cause I just tried.
So let's do that. So number 7 is zoom trig. So that is a typo that we'll fix on the notes. So z trig.
Mine still didn't do
We'll give you, oh, I have other stuff.
Freaked out.
Okay, so go to your y equals menu, and I realize we have a couple settings we need to fix. On my y equals, I have a function in there. I need to clear that out, and I need to go to the top. I need to go to the top and turn plot 1 on. So this is in your y equals menu. You should do this the first time. I wasn't thinking about the fact that in my other math class we were doing something else. If you turn that plot on, it might work. So now let's try doing zoom and see. Actually, zoom stat, z stat probably does work for this. So let's try zoom stat, which is number 9. And I have a box and whisker plot, so let me try something else. Okay, so if you're not getting the graph that you want, you can go into the stat plot area, and on this, I need to change it back to a scatter plot. And you need to make sure that it's wanting you to use L1 and L2. In the stat plot menu, if you wanted to use other columns, you could go in and change that. So second, and the y equals key goes into stat plot. You want to make sure it's turned on, that you have a scatter plot, L1, L2. The rest of this is not a big deal. So second in your y equals key,
Mine
second.
doesn't look like that, so how do I
It'll
do
look a
scatter
little bit
plot?
different, but it'll be the same stuff. If you do second and your y equals key, you get this. So you have to select plot 1. And then this is how you get here. Okay. So I should have started with that. Sorry. I should have had all of our calculators set up before we started this. But now, let's try to do a zoom stat. And you'll get something like this. So this is zoom stat, not z trig, which I was thinking the actual directions are okay. And you can see part of a wave function, a sine or cosine function. So you can see that it's going to cycle. If we had the temperatures for 2 or 3 years, you'd start getting 2 periods, 3 periods, however many years you had. You would see the temperatures go up and come back down, because that's what temperatures do throughout the year, because you have summer and winter and spring and fall and all of that. All right, so we graphed it just so we can see this. If we want to see the equation to actually write down the model, what we're going to do is we're going to hit the stat key again, and we're going to right arrow over to calc, and we want to select option C, which is a sine reg. I'm going to go up because that's a little faster than down. And what the calculator does, it's going to make each of these a sine function, even though some of them would be better off as cosine. We're going to pick, it just does the sine function, so C. And then mine's going to have a bunch of crazy stuff here. What you need to make sure is that it has L1 and L2 somewhere on there. And stuff will come on the screen, and you want to hit enter. So depending on if you have an 84, an 84 plus, an 83, it'll look a little different. So you might have to hit enter a couple times. And you're going to get a bunch of information. And this information is going to give you A, B, C, and D that goes into the equation, and we can just copy it down. So y equals 4.24 sine parentheses 0.51x. And it says plus C, but then C is negative, so I'm going to do minus 2.44 close parentheses plus 84.34. So I'm rounding everything to 2 decimal places. So that's your model. So it has plus, but it's negative. So I made it minus. You can put plus negative in there if you want to, but this is easier. All right? So then what we're going to do is we're going to do the same thing for Chicago. The good news is we already have the months in. So if we go back to your stat key, we want to edit, and we're going to clear out all of those nice warm Honolulu numbers, and we're going to put in Chicago's numbers. So January, it's a little colder in Chicago, 29 degrees. 33.5 in February, 45.8 in March, 58.6 in April, 70.1 in May, 79.6 in June, 83.7 in July. So if you look, July is pretty close in both places. On the 8th month, we have 81.8 and 74.8, 63.3, 48.4, and 34 degrees for December. And I hope I didn't make any mistakes. So we just put all the temperatures in for the corresponding months for Chicago. And this will not be so hard the second time because our calculators are set up to do this. So we're going to, you could just push graph because we set this up already. Yeah. No, we can't. We have to do zoom stats, so number 9.
Okay.
And then we get kind of a wave function again. So cool, we can see it. Not too exciting just to look at the graph, but it kind of helps us know if we did this right. And then when we want to find the equation, what we do is we're going to hit stat and then arrow over to calc. And we want option C. We want a sine regression is what that stands for. Sine reg is sine regression model. And mine gives this screen that I don't think most of you are going to have. You'll get this something like what I just had that you have to push enter.
9?
So you're going to have to just push enter a couple times.
The exact same thing as the other one.
So then just push enter. You haven't done all the steps if you still have the same information as the last one because your last one is still on the screen. So make sure you're going through the steps. Stat, go over to calc, do C. If you typed in all the new numbers and you hit enter, it should change it and your numbers will all be very different.
It's still all the same.
Okay, I'll have to look at your calculator because something's not.
It just keeps like...
So I'm going to go ahead and write this down while you're walking up for me to help. Calculator stuff's always interesting. So I'm going to have y equals 28.58 sine 0.47x minus 1.81 plus 55.71. So I'm just rounding all these numbers off to and then putting them in where they go. You have to hit enter. But you have it on there too many times. It was on there 4 times.
I know that it just didn't clear the other one.
So you have to hit the clear button and then do stat, calc, C, enter, and it's all good. So make sure there's nothing else on the screen when you do it, and I think you'll be all right. It had 4 different sine regs on there. So, all right, did everybody get this to come up on your screen? Are we all doing this on the calculator with me so you know how to do this?
Actually,
I see one with a case closed, which makes me suspicious.
That would be Anthony.
Okay, so if you don't understand the keystrokes, like it does look a little different on your calculators, you want to be practicing this now because this will be on your test. All right, so moving along, I'm going to explain what all of this means, what these numbers are going to represent for Honolulu and Chicago. So for these, my X for both of them was time. So the X in here is the month or the time, T for time. Over here, the X is the month for time. And then the Y values that we use, both of these we use separately for Y, were the temperatures. So Y is the temperature that you have coming out. So in theory, you could put any month into this and it would give you the average temperature for that month out. Or if you put a temperature here, we should be able to solve and figure out about what month it is or give a good estimate. So what the other numbers are standing for, this number right here on the end is telling us that the whole graph got moved from the x-axis up 84.34 points. And that would be the midline for your graph. And that gives us an average temp for the whole year. So the average temperature in Hawaii is about 84 degrees. You come over here to Chicago, this would be my midline number. That's the average temperature for Chicago for the whole year. If you were to average the averages for each month, that's what you get. So that's how we can use this equation to answer questions. Okay, and on 3 and 4, it's going to ask you how well the models fit. We have to enter all the data. Again, I meant to do this before. For what we're looking at, I'm actually just going to skip that part. I know that makes people sad. What you could do is you could enter this equation on the y equals while you still have the points on there. I guess I could have done 4. But you just put the equation on the y equals and you graph it over the top of the dots and you go, oh, it fits well, or it's a little off. I'm not super worried about that part of this for right now because we've done a lot of that with other functions. What I'm more worried about is can we use these models to answer these questions? So it says use the models to estimate the average annual temperature in each city. Which term of the models did you use? Explain. I just talked about this. So if we go back up, it's this number on the end that's the average temperature for the whole year in each city. So I'm going to put H for Honolulu. The average temperature was about 84 degrees. I'm just rounding that off. And for Chicago, I'm going to round it off to about 56 degrees. And then which term of the models did you use? So when you had your thing on the screen and it gives you this equation, when it asks which term, it's basically trying to figure out if you're using A, B, C, or D. Which part of the equation did we use? D. So we use D. So this is an answer, this is an answer, and we use the last part. And that's the part that tells you about the translations up and down. Okay, what is the period of each model? Are they what you expected? So we're going to calculate the period the way that we've been doing. Period is 2 pi divided by b. And they do use b on these equations. So we can get b out of each equation. That's the number in front of x here and the number in front of x here. And we're going to type it into the calculator and actually divide and get a decimal, which we wouldn't do in just a straight trig problem, but this is an application. So for Honolulu, we're going to take 2 pi and divide by 0.51. So we can just do that on the calculator. 2 pi keys over there, divide by 0.51. And we get 12.3, which means that the pattern for the temperatures is repeating every 12.3 months. It's close. And then let's do the same thing for Chicago. So Chicago, so that's for Honolulu. I'm going to put H, and then this would be months. And then if we do the same thing for Chicago, we're going to take 2 pi and divide by 0.47. And it comes out for Chicago 13.4 months. So the period should be what?
12.
It should be 12 because there's 12 months in a year. So is it what we thought?
No.
It's a little off. I wouldn't say it's hugely off. Honolulu was pretty close. Chicago is more off. So we could say Honolulu's period is close. Chicago is more off, in quotes. So they're close to 12 months, but this just doesn't look quite right. And the reason why is because we can't fit an exact trig model to those temperatures. If you had the average temperatures for probably longer than 1 year, you might be able to come up with a little bit better thing, but we're working with just 1 year's data. Okay, so let's go down to number 7. Which city has the greatest variability in temperature throughout the year? What factor of the model determines this variability? Explain. Variability, if we're thinking about a wave function, would be how far it's going up and down. Okay, so how much does it vary from that average at the midline? What part of my equation tells me how far up and down it's going to go from the midline?
Your amp.
Your amplitude. So if I'm looking at my two equations, which one has a bigger amplitude?
Chicago.
Chicago. Does that make sense? So does it make sense that Honolulu is only varying about 4 degrees up and 4 degrees below the average, but Chicago is varying more like 29 degrees?
Yeah.
Yes, it makes sense. So, so we can say Chicago has more variability. We used A, which is the amplitude, to figure that out. And basically to explain, basically this would be, the amplitude would tell you how far up and down the values go from the midline, which would be where your average is. Sorry, my handwriting is getting a little bad at the end of the day. All right, spring break is the last week in March. Which city would be best? I didn't write this. I'm assuming they like warm weather, but that may be a bad assumption. So if we look at March and what the average temperature is in March for these two, you could just kind of look back at the data. It's definitely going to be warmer in Honolulu in March than it is Chicago, but it just depends on whether you like it to be hot or not. So I would put a little qualifier in here that this is basically going to be an opinion the way that it's worded. But we say if warmer is better, then Honolulu is the pick for March. If they are going in July and you're just looking at temperature, there isn't that much difference. But in March, for spring break, there is a big difference. And then whatever you're planning to do on spring break would probably influence that more.